Okay, we will enable the screen. We are sharing our screen, but we don't have anything yet. Now we'll have our open board also. So hopefully you are able to see our screen, and we will start discussion with arrays more elaborately. So I'm just doing a brief recap since we are meeting after a gap of about 8-10 days. So we said an array is a contiguous location of memory. It's a contiguous allocation of memory. How big the array could be depends on you. And the array's indices start at 0. So the index starts at 0 and goes up to n-1, assuming that n-1 is the size of the array. So this is 0 to n-1, n being the size of the array. So how do I declare it programmatically? I say int if I want an array of ints. So int arr 10. So if I want an array of 10 integers, okay, I do this. So int arr 10. This is how I create an array of 10 numbers. So the numbers, the array values or array indices will be numbered 0 to 9. That is n-1 is 9. So I can access the elements by using this. So I can say arr of 0 is equal to 5, which will install a value 5 in that array. I'm having a bit of difficulty putting the semicolon. So this is array of 0 is equal to 5. So this is 5. We'll put it here. Then if I say arr of 4 is equal to 7, you know what it does. This is index 0. This is index 1. This is index 2. This is index 3. This is index 4. And in that I put a value 7. So that is what an array will enable me to do. So I put the value 7 here. These values I don't know. They will be spurious. That means they will have some garbage values. So it's always better to put zeros or something in the array or initialize the array. So what we are going to do now, what we are going to do today is, this is a brief introduction of array. Also we said that the name of the array is also the address to the first element. So when you do scanf, you don't have to say ampersand of arri or ampersand of arr or arri. No, if you're saying arri, you have to say ampersand. But if you're reading the whole array, which we will not do now, but we'll do it when we deal with strings, we will have to do that. Okay, so we will now today set ourselves a question and then address it. So the thing which we are going to do today, let me define the problem. So we are going to create an array of n elements. So we are going to create an array of n elements. We are first of all going to allocate a big array, out of which we are going to fill n elements. You will soon see why I do that. So I'll create an array of 100 elements, out of which I'll ask the user for the n, and I'm going to use only n elements out of the 100. We are going to assume that n is less than 100. The n is given by the user. So we're going to read n. That tells how much of the array the user is going to use. So we are going to have that array. And after that, what we are going to do is we are going to fill up the elements of the array from the user using a scanf. So you imagine we have, let's say, array of 100, out of which we are going to fill, let's say, n is 10, or it could be lesser. And we are going to fill up these 10 or even lesser elements from the user. Okay. Then, so we are going to ask for n. Then we are going to ask for these elements from the user. Then we are going to ask for an element to be searched here. So I'm going to ask for which element do you want to look for. So I'm going to ask for element to be searched. Okay. Once I get the element to be searched, then I'm going to go through this entire array again and look for that element. Now two things may happen. I may find that element. If I find that element, very good. I will return the index of that element, and if I don't find it, I will say element not found. So we'll use a bit of break and all that also here, and you'll understand why I'm using a break. So it will help us revise a bit about breaks also, and so that we can easily break and then decide whether the element to be is found or not. So we will say if element is there, we will give the index which is 0 based. So if element exists, we will return the index. We will give the index, and if the element does not exist, we will give a message element not found or something like that. Okay, so this is a very simple program. We are going to start writing this program, and we are going to then use this program for something else a little more complicated little later in the second phase. So is this okay? I mean, this is what we are going to do. Is everybody clear what we want to do? Okay, so I'll go back to the chat and find out whether you guys are in sync with me in terms of what is it that we are going to do. Okay, so I think we have now, you close Kalman? I think still somebody is raising hand. Please don't do that. So we have close to about 23 people here. So which is good. That's the beauty of this system, that it can reach n number of people and all that. So now what we'll do is we'll open a practice question, and with my colleagues here, we're going to start writing code. We are broadcasting this from the college, by the way. So we are not afraid of COVID, or we are not afraid of anything at all. Okay. So we opened a practice lab question. It started there. So you should also see the practice lab question open in front of you. Okay. Yeah. So I am hoping that you are able to see practice lab. Just practice lab of Jan 18th, right?
18th.
Jan 18th practice lab question. I hope all of you are able to see it. Okay. Yeah, so please use that for this code, so that I will be able to know whether you are able to do or not. So we are logging in as student, right? Okay. So we'll just log in as a student with a student credential. Just give us a couple of minutes. Okay. There we are. So we are opening the practice lab of January 18th, and let's see whether we can make progress. So we'll keep watching whether our internet is doing okay or not. Yeah, it seems okay at the moment. Okay. Why not?
Live then, live.
Acha, YouTube.
Yes.
No, we don't use YouTube. Okay. So we'll go ahead. Yeah. So let's start writing code. We can make the screen a little bigger. Okay. So we say hash include
Caps.
hash include stdio.h as usual. We are beginning to write the program stdio.h. I really recommend that you guys should start typing also, because we are going to take this program forward. This is just the first step of the program. So we are going to create a fairly big array, let's say of 100 elements, This is how we create an array of 100 elements. Now, having created an array of 100 elements, I think we'll need an I and an N for us to iterate and to accept the values. So now, printf, enter the
n value.
Enter the number of elements. No.
Okay.
Enter the number of elements. See, we are taking the number of elements from the user, but we have already created an array of 100 elements. So we are assuming that the number of elements the user gives is less than that. Okay. So backslash n. So backslash n. So we are getting the number of elements. Now we are doing a scanf of %d. And we will say ampersand n because we want to give the address whenever we are reading data, and that is the irritating part in C, because when you print data you don't give an address. When you scan data you need to give the address of the variable, so that is ampersand n. Now what we are going to do is we are going to go through the loop. No, we'll ask element by element. We'll enter a loop.
Statement.
Okay. Okay. Enter the elements. Fine. So now we are going to ask the user to enter that many elements. So for I equal to 0, I less than n, these many elements we are going to take. I plus plus, and I'll elaborate as we go on. Scanf. Wait. Scanf. Now remember we have to read the data in an array. So when we are reading the data in an array, when you are reading the data in an array, remember here we were reading the data directly in the element, so we provided the address. I already told you the name of the array is the address of the first element. So we don't need to provide address, or we should not provide when you are reading into an array. So our scanf is going to look like this scanf %d %d. Okay, this is %d by the way. Okay, %d ARR of I. I am not going to, oh sorry, because I am reading element by element. No, I'm I'm sorry. I am reading element by element. I have to provide ampersand. If I was just reading the complete array, which I don't intend to do, but will happen when we read strings, here I have to say ampersand ARR of I. So because I'm reading each element one by one, okay, because we have not talked about how to read a string or something, basically this is fine. So we read an element by element, so we provide ampersand of ARR I. So this is how my scanf is going to look like. Scanf %d ampersand of ARR I, because I'm reading element by element of each element. So I have to provide the address of that element. ARR I is the element in which I want to read the data, and ampersand ARR I gives me the address of that element. So having said that, let's proceed with the code. So we'll clean off this part and we will start writing the code. %d ampersand of ARR I. Okay, so we have read the data. So lines 7, 8 and 9 will enable me to read the data, that is the loop to read the data. Now what am I going to do? I am going to ask the user which is the element he wants to look for. So we will say enter the search element, that is the element he is looking for in this array. Okay. So printf, we will say enter the search element, that is the element to be searched, or you can say the element, the search element or element to be searched, doesn't matter. So okay, so we are asking the user to enter the search element, then we will read in the search element. Now we don't have an variable for doing that, which is a problem easily solved. So we'll call it S, the search element. So let's call it S. We can call it whatever you want. %d ampersand of S. Okay. So we are reading in that S also, the element that we are going to look for. So where are we so far? We have entered, we have asked the user for the number of elements. Then we have read all the n elements from the user into our array by doing this. For I equal to 0, I less than n, I plus plus, ampersand of arr I. We have read these elements into the array. And then we are saying enter the search element, and then we are saying scanf percentage d, ampersand of s. This is the element which needs to be searched in the array. And after this, we'll commence our search, which is what? We will go through the entire array. So we will search means what? We'll have to go through the entire array, go element by element from in the array, and whenever we find the element equal to what we are looking for, which is s, we are going to say I found it, and I'm going to use a flag. I think I explained the flag last class. No? Did we talk about the flag? Otherwise, this is a good point. Okay, we didn't talk about the flag. Okay, so this is a good point or opportunity to learn about the flag. You will see what I'll do with a flag. Flag is some kind of variable which indicates why did I break. You will understand, and I'll elaborate on this. So we're going to look for this element in this array, and if we find it, we are going to break, but by setting a flag. And the setting of the flag will say that yes, I have broken because of finding the element and not because coming to the end of the for. You'll understand what I am saying in a moment. And then depending on the flag value, I'll say I'll either report the index or I'll give a message element not found. Okay. So let's try this, and let's see how we can write the code. So we'll erase the. We have also introduced a flag variable. At the top, you can see he has added on line 3 a flag variable. So let's start now searching. How do we start searching? So initially, let's make flag equal to 0. Okay. So let's make, you will understand why I am doing that in a moment. So I am making flag equal to 0. Now I am starting the search. How do I start the search? I again use a for loop. For I equal to 0, I less than n, okay, I plus plus, or I equal to I plus 1. Right now it doesn't matter. So I am going to compare each element of the array with s to check whether I found it or not. Okay. So I am going to say if ARR of I, remember ARR is my array, and ARR of I enables me to look at every element of the array. If ARR of I equal to s, then I have found what I was looking for, because s is the element I am searching. Then I will say two things: flag equal to 1. Okay, I'll make the flag equal to 1, and my value of I will be very important to me now. But since I is already created, I'll not bother about it. The value of I will be the place where I have found the data, right? The s, where I have found s, will be given by I. So I have flag equal to 1. Okay. Now I'll do a break, because there is no point for me to stay in the loop, because I found what I got. Now these two are important lines here, and you will understand its import or its purpose in a moment, but let me still elaborate. What am I doing? I am going through I am looping through the entire array. Okay. I am looping through the array. Okay. Once I am looping through the array, I am checking whether any element in that array is equal s. Remember, I am using equal to compare. So if the value I find is equal s, then the flag which was 0 so far goes to flag equal to 1. I am just saying, oh, I found the element, I am raising the flag. I have raised the flag. Imagine this like a flag, and I have raised it, and I have broken. Break. So this break will take me out of the innermost for loop or any loop. So it will take me out of this for loop. Where does the for loop end? The for loop ends here. Remember, this is the if and this is the for loop. So the for loop will end here. Not here, sorry, here. It will take me out here. Okay, now let's talk about here. Let's debate a little bit about where my horizontal arrow is. When will I come here? Because of two reasons. Okay, one reason could be that I came out of this loop by putting a break. I came out of the for loop. That could be one reason. Or if I did not find the element at all, if I did not find the element, then also I will come out. That is, I compared all the elements in the array with S. None of them compared with S equal, none of them was equal to S. So I came out of the for loop. So I will come out of for loop because of this reason or because of not finding an element. So when I come here, there is a thing which I need to do. First of all, I need to tell the user, did I find it or not? So if I write here, if flag equal 0, equal 0, it means that I never found the element, isn't it? If I had found the element, the flag should have become 1. So I reached here because the flag was, and the flag is 0, means what? I did not find the element. So I will say element not found. I'll give a printf, element not found. Okay. Otherwise, if flag is 1, that means I came out here and my I will be my index. So you will say else. Okay. Here you will say else. I found the element, and where did I find the element? At I. Element found, and I will say equal to, I will return the index where it was found, that is the I. So I will report it that way. So now do you understand why I am using a flag? The purpose of the flag here is to tell me when I came out here, was a flag up? If the flag was up, then the element was found. If the flag is not up, then the element is not found. So if the flag had remained 0 and I had come out of the for loop, it would have been because I did not find an element at all. The element which I was looking for did not happen. So or is not there in the array at all. So that's why the importance of the flag is important. So if I had used this, because the clever use of this flag, I made it 0. If it remains 0, that means this condition was never encountered and I did not come out because of anything where the element was found. It is still 0. So I would report element not found, else I would say element found, and the I would make sense. Okay. So this is the reason I use a flag variable. This is a very common trick. We call it the flag trick. Okay. So this is the flag trick. It's a very common trick used while coding, and we will use this trick now to write code. So let's get down to it and let's see whether we can write it properly. Yeah, we'll erase it. Sometimes you get a nice eraser which will erase everything. Sometimes you get this. Okay, so let's write this after the end of the for. Okay, the for ends there. So no. Now, if flag equal 0, it means I did not find the element. That means the flag never became 1. So we are giving a message, element not found. Not found. Okay. And else, that means the flag is 1, because that's the only two values in this program which a flag can take. So we need to remove that switch. Yeah. Else we are going to say element found at equal to %d, and the value of this %d is what I am going to provide now. Is what is
we have to introduce position and will increment.
No, I I is enough.
But it is out of no, sir.
No, no, I has been created at the top, no? I is not created in the loop. So I. So element found at %d I, because I is right there, and we have I as the place. Not a very good use of I, but for now it will work. So this is our program where we are saying element found at a particular index or not. Okay. So let's play with it a little bit and see whether it works for us. Okay, enter number of elements, let's say 5. Okay, enter the elements, let's enter 10, 20, 30, 35 and 50. Okay, so 5 elements we have entered. Now it is going to ask us for a search element. Now let's do a successful search. So let's enter 30. So it says element found at 2. Now it's obvious why it says element found at 2. See, this is index. Okay, let me
Use different
color.
Yes.
This is no. Okay, I'll have to go to
Open board.
Go to
Okay, so operate.
I'll change the color to green. Then close your desktop and then right. Okay. Let's see if this works. Yeah. So this is index 0. This is index 0. This is index 1. 30 is index 2. 35 is index 3. And 50 is index 4. So that is how this whole thing works. So I entered the search element as 30 and it said the index at which it is found is 2, which is correct. See 0, 1, 2. This is where 30 is, right? So 30 was found there and it said element found at 2. Now let's run it for an unsuccessful case. Let's first get rid of the. Yeah. So let's run it again. Again, let's say 5 and say 10, 15, 10, 15, 20, 25, 30. Okay. And the element we are going to look for is not going to be existing, so we'll say 16 or 40. Okay. Then it will say element not found, which is what we are expecting our program to do. So it will accept the number of elements, read in the entire array with that number of elements, 5 in this case, and then ask us for the search element, and if it is found, it will say found at so and so index, otherwise it will not. Okay. So now what I want you to do is, I think most of you are writing the code in your practice lab. Now, okay. Okay. Now, I don't know for what purpose the error is there. The index starts from 0. Yes. Yeah, we will soon tell you where to find the recorded class.
Upload in study material.
Okay, it will be in study material, by the way. Okay. Now we have done this program. Hopefully, you have finished writing the program. Is it done? Yeah, flag is Boolean. We don't have Boolean unfortunately in C. Okay, so let's see how. So if you have finished writing, please submit it for evaluation. Though there is no test case, but we will know that you have submitted. So please submit it for revaluation. So we'll look at a few code and then we'll proceed. So now I am going to give you an exercise which you are going to do, and then we are going to proceed. Okay, I am going to give you a little more work on arrays, and then we are going to take the next example. At this stage we believe in going very slow, so we cannot, yeah. So yeah, some C will support it, sometimes it will not. If it is defined true, we can do it. Okay.
Show the code.
So we'll show the code in a moment. Yeah, we'll show the code. and then I am going to extend this problem a little and ask you to do a little more thing. Okay. Okay. I am going back to the code. Okay. But please, as we type, please don't make a mistake. You need to type the code also. Okay. The whole idea of giving you tessellator is also to be able to do that. Now, if you see our window, this is what is the code we have typed or entered, and now we are going to extend it a little bit, and you are going to say that okay. Now let me tell you how we will extend it and ask you to make a small change to the program. But before that, let me just see how many of you have actually done it. So we are going to the student portal. You can see also yourself on the screen. What has been, so about 134 graded. Please go up. We want this number to go up, please. The stars won't come. No, go up. Bus. The stars won't come, but the G number, that is, you're seeing this G. This should go up. This means they are graded. Okay, these are people who are just saved, but they should finish it and do it. Otherwise, if this number is too low, or even the combined number is too low, as it is in this case, it tells us that you just are goofing off. You are not able to type code. You are just there because you are there. I mean, that's all. So you are not doing anything productive. So it's very important for this number to go. Now on your tessellator or on your telescope, you have that window for running and grading. Running is the rocket, grading is the tick mark, the correct tick mark. So you need that tick mark to be also pressed and the program to be graded. It doesn't have any test case at the moment, but you can grade it. We will know that it's graded, so it's completed to some level. Okay. Now we can look at a few code. Maybe this is just a copy code, so there's no point. But soon we will ask you. Now I am going to ask you to write another program. Okay. And then we will extend this program. But for the time being, I'll open another practice lab, which is no. Let's not open it first. Let's explain the problem first. So I will explain what I want you to do. Listen to me very carefully. So let me elaborate what I want you to do. Okay. Now I want you to implement what is called A minus B on arrays. Okay. Now you will know what it means with that example. So I want you to create two arrays. The first array could have n elements. Now listen very carefully. The first array has n elements. So you create two big arrays of 100 each, ARR1, ARR2. Please listen carefully. Create two arrays, A and B, of size 100. Okay. Each. Then ask for n. N is the number of elements in array A. Number of elements in array A. Okay. And B is then you ask for n, this is n, and m, this is the number of elements in array B. Okay, so this is n, this is m. So you have to first create two big arrays of 100 elements each, call it A and B. Then number of elements in n you ask for, and then m, number of elements in B you ask for. Then read n elements in array A, okay, and read m elements by writing a loop like we did now. M elements in B. So you have read A and B. Now what I want you to print is all those elements which are in n. You'll need a little bit of thing. You'll use for within for, which is called nested for. This will anyway help you also do it, and we'll solve it together after that. So for within for is a nested for. You will have to use it. Now listen to my question carefully. You will have to tell me which elements are there in A. You'll have to print all elements in A which are not in B. That means the element should be there in A and should not be there in B. So if the element is not in B, okay, let me make it first A intersection B. It's easier. Let's first do A intersection B, which are in B. I am changing the question a little. This is easier to do than the other way. So print all elements in A which are which are in B also. So we are writing A intersection B. I am repeating. Print all elements in A which are also in B. Okay. The element, if it is there in A and if it is there in B, then you should print that element. Okay. So if suppose A has 1, 2, 5 and B has, let's say, 3, 4, 5 and 7. 3, 4, 5 and 7, yes. So A has 1, 2, 5 and B has 3, 4, 5 and 7. Then I should see on the answer I should see 5. Okay. If on the contrary, if I have here elements that is here, n is 3, remember, n is 3 and m is 4. Okay. So in a similar way, let's say if A has 1, 2, 7 and B has 2, 4, 5 and 7, then I should see in the output 2 and 7 getting printed. I should see these two. Okay. So you will use a for within a for. Now I am not going to immediately tell you. I am going to allow you to, some of you to struggle. Some of you will be smart and be able to do. Okay. Now I want to see, because some of you have a tendency to go to the net and cheat. I want to see only array A and array B in the program, please. So don't call your array by any other name. Call it A and B. And the number of elements in A should be n, the number of elements in B should be m, and you should have a nested for, and I want to see what are the elements which are common to both, okay, which are there in both. Okay, print all the elements in A which are also in B. I want this. I don't know whether you have understood the question. Okay, let's see on the chat. Okay, let's see on the chat. Is the question understood, please? You will have to write a for within a for and we will proceed from there. Okay. So what I will do is, it is 10:20 now. I will give you time till 10:30, 35. Okay. Yeah, we will open the practice code. Yeah, we will open the practice code. Don't start writing. We will open the practice question. The practice lab 1 is what you have to write it in.
Yes, sir.
Practice lab 1, please. Okay, we have opened practice lab. Yeah, this is A intersection B, kind of. Okay. So I'll give you 15 minutes. After that, we will discuss the solution, and by doing that, we'll understand how to do this. Okay, we'll then do it step by step, and you should be able to do it. Now, for your simplicity, we are going to open up the previous practice lab. We are going to keep the previous practice lab open. For those of you who are want some help, you can see. Okay. So, okay, let us open. Huh?
You have to show the code. This one.
Yeah, we want to show the code. That's all.
Okay.
So we are showing you the code, but you don't do it in practice lab. You do it in practice lab 1. Okay, this is the earlier one. So we have opened practice lab 1. So please do your stuff in practice lab 1. We are showing you this code for the benefit of people who are struggling with the earlier program. Yeah, which one?
Some program.
Which program do you want to run? Anji, Teja? The one which we just wrote? You can run it on your own, right? So what's your problem? Yeah, once you are done, please post it. Tell us here. You can write int main also or void main, it doesn't really matter.
Can you check my Sai Vishal?
Yeah, we will. Soon. We are noting down your name. We'll go in that order.
Sai Vishal.
सर इसका रिकॉर्डिंग का जरूरत है
उधर हो रहा Sai, Prem Sai, is it today's thing you didn't understand, or is it in a general sense that you are saying? Since the for loop, okay. Are you typing code with us? Okay. Now, when we explain this program, listen to us very carefully, and then ask me specifically what you are not understanding. Because generically speaking, I did not understand doesn't help anyone. We will ask you specifically at every point, what is it that you didn't understand? You have understood scanf and printf? Okay. So for loop, maybe today when we write it, right now I'll write 2 for loops after this. You should make a little bit effort and you will get it. Okay. Now we will explain, and you will have to tell us exactly where understanding is stopping. Okay. Now that applies to everyone, please. If you are not understanding at any point, just put it on the chat that you are not getting it. We'll monitor the chat as we talk, go about, so that I can see the chat as we are talking. Okay. Now this can we? No. We have to have one window open on chat.
So we have to set up separate thing in this. I mean, actually this screen and this screen same, no? It should not be same. So that we can see the chart.
Correct. So how long does it take? 1 minute, no?
Yes, sir. We'll do that.
So he has to log in as a student here.
Yes, sir. We'll do that.
And you should do this.
Fine.
Yeah, we'll start.
ఇక్కడ అవసరం లేదు స్క్రీన్.
इसको क्या करो बोल रहा है?
हम बोल रहे थे इनको सेपरेट स्क्रीन इसको करना है.
Separate CPU अलग.
CPU sir.
Obviously, no.
CPU is one more CPU you want to set up.
Obviously. Otherwise, how can we get?
No. This, see, you are logged in here.
Yes, sir.
Correct?
Yes, sir.
Now somebody has to log in as a student, no? And so
we need separate CPU for that. Otherwise, what
so
are the
you are with this CPU, is it?
Yes, sir.
Okay. No, or you can monitor here, no?
That's
What do you need?
But if you want screen.
No, this is okay. Okay, we'll start in about 2-3 minutes. We'll start talking about this code. So what we'll do is we'll pick one of the students' code first and use it to explain, and then we will go ahead and correct it if necessary.
First name.
Vishal sir. So I'm Vishal.
No. Are you on the other window?
Yes, sir. On the
Chat
chart.
windows.
Yes, sir.
So keep monitoring the chat window.
Sorry, Vishal.
Okay, we are now beginning to look at code. So we are going to the first person who said done. So I'm looking at that code. Okay. Yeah, this code looks okay to me at a prima facie level. Okay, so let's start
Run.
understanding the code written by one of your classmates or whatever. So we'll try and understand this code. No, just check whether the net has become slow.
Yes, sir. But we can see the code. But
No, voice has to also go. No?
Yes, sir.
It's okay. It's okay. Here, so. Yeah, fine. So we will discuss what somebody has written. So look at it, and I'll try and go really slow. And you know, somebody in your own class is able to write, so you should focus on that. So what is happening here? Okay, I'm going very slow because somebody has very nicely written the program for us, and I like it already. So we have int main. Now somebody was saying, can this be void main? No problem. If you want, you can write void main. So int A100, B100. We are creating array A of a very big size, B of a very big size. Then we are going to use I and j. I think that is used to loop through the array. We need two variables, one for one array, one for the other array. And n is the number of elements in A, and m is the number of elements in B. Okay. So yeah. So he's saying enter elements of array A. He's reading scanf ampersand n. So first he will read the number of elements. So let's say 5, and then he will read each of the element in the array I. Okay. Now here let me pause. Okay. So now let's look at this for loop. Okay. What will this for loop do? So it will start from I equal to 0. What is the use of a loop? To do the same thing repetitively. What is the repetitive thing that we are doing? We are starting from I equal to 0, going up to I less than n. Why I less than n? Because in an array, the indices start from 0 and go up to n minus 1. So till it is less than n, we are going to repeat this. So this kind of statements are going to repeat every time. So for I equal to 0, I less than n, I am going to do this. And what this means is, this is actually I equal to I plus 1. Okay, it is written I plus plus, but it is written I plus 1. Now the question, so let's delay this for a moment. Let's understand the body, and at the end of the body, this I equal to I plus 1 happens. So what does the body do? Body does scanf, which is reading from the keyboard. What is this percentage d? Reading an integer data from the keyboard. And what are we doing here? Ampersand of A of I. Now this construct A of I or ampersand of A of I means what? I am reading the ith element of A. Remember, every time I have to read a different element. So I am reading the ith element of A. So first time I will be 0. So I will read the 0th element of A. Now why do I have to say this ampersand? This means address of. So I have to supply the address of a particular variable before I can do scanf. The data cannot be read until you say I have to supply the address of that data. Which is where is the data I want to read? A of I. Why A of I? Because I am reading the ith element. So I am reading ampersand of A of I. So this is to supply the address. Now how many such elements am I going to read? I am going to read n such elements. Because n is the size of this array. I mean, n is the number of elements in the array. Size is very big, but the effective size or effective number of elements is only n. So I am going to read that. Then I am going to say enter array elements of array B, and I am going to repeat by and large the same process. Scanf percentage d ampersand m. Very nice. Then what am I doing? Just like with I equal to 0, now he is using j equal to 0, which is fine. You can still use I if you want. For j equal to 0, j less than m, j plus plus. Same way. So till till I am filling up all the elements of the array B from 0 to m minus 1, because j has to be less than m. Till then it will keep reading, and for reading I have to always supply the address. So at this stage, what have I got? I have got array A filled and I have got array B filled. Array A may have some elements. Let's say notionally I entered n equal to 3. So that means this loop ran 3 times and it picked up array A. So let's imagine array A is 2, 5 and 7. Okay, these are the elements sitting in array A. Now for a similar example, let's say B, the number of elements was 4. So M was created as 4. That means here 4 was entered, and then the data was taken. And once that has happened, now let's imagine B, which has 4 elements, 1, 2, 3, 4, has values 5, 8, 7, 3. Okay, these are the values which are there in A. This is A, this is B. Okay, now what do we need to do? We need to write a for within a for, because we have to pick up all the elements in A which are also there in B. Okay. Now, how are you going to do that? Look at the way Vishal has done this. So, for I equal to 0, I less than A, I less than n, I plus plus. I plus plus is done at the end, where you have done all this, and then it goes to the next value of I. So I plus plus actually happens at the end of the for loop here. Just before the end of the for loop, I is made I plus 1, incremented, because till then I is 0. Okay, this is done at the end. So let me put it like this. It is done here. Okay. So initially what is I? I will be 0. Okay. Is 0 less than n? What is n? N is 3. Yes, n is 0 is less than 3. What will happen now? Will I plus plus happen now? No. So I is still 0 and it is less than 3. What will happen now? For j equal to 0, now there is an inner for loop. This is called the nested for loop. Okay. So this is nested. For j equal to 0, j less than m, j plus plus. So we are going from 0 to m, because remember, for each, so the way it is going to work is, he is going to take each element of this. Right now I is 0, he is going to take each element of this and compare it with this, this, this and this. That's why the inner loop B, which runs from 0 to m, is like this. If A of I, what is A of I right now? A of I is I0, remember? So it's 2. So 2 is going to be compared with 5. Okay, look at this. A of I is 2, and it is going to be compared with B of 0. Then this is compared with B of 1. Then it is compared with B of 2. Then it is compared with B of 3. Okay, imagine when M is 4. So it is going to be compared with all these elements. This is what this is doing. So each value of I, of A of I, each value of A of I is compared with all values of B of j. See, A of I is defined here and B of j is changing every time. So it is compared with every value of B of j, of B, and if any one value matches, then he is printing that value of A of I, because we are doing A intersection B. So that means this value is common both in A as well as B, so he is printing it. Okay, perfectly fine. Then what he will do? He will go with next value of I. I will now happen I equal to 1, because I was 0, now I will become 1. So when I becomes 1, what is A of I? A of 1. A of 1 will be 5. Why is A of 1 5? Look at this. A of 1 is 5. So now that is getting compared with every value of B again. So now 5 is getting compared with 5, 8, 7 and 3. This is how it will run. But when it is equal, which will happen when 5 is compared with 5, we will say printf A of I. Okay. Now he could write a break here, because there is no point comparing the remaining values with this. Okay. So you could optimize a bit here, by writing a break, because now that, so it will come out of the inner for loop, and remember, break takes you out only of the inner for loop. It will not take you out of the outer for loop. One break can take you out of the inner for loop. So after this printf, he can write a nice cute break which will take me out of the loop, because anyway he has processed it, so there is no need to compare. He has already found that one element of this is equal to this element, so you can put a break here and come out and then start with the next element of I, so which is 7, and then compare 7 with each one of them, and the moment it is equal, print it and break out of the inner for loop. So you don't have to proceed, keep doing this inner for loop again and again once you find a match. Okay, so this is how we could improve it. Okay, now I don't know how many of you have done it. I hope a good number has done it, but if you have not, then this is what is the code. This is the correct code, and we will just demo it, run it once, and just run it with this data and see whether it is functioning. So we'll rub this off. Our screen has got cluttered. Okay, we are erasing our screen and we will now proceed. Okay, so
shall we add?
You can add break there. Okay, we are just improving the code little bit, but the code is fine by putting a break, because we don't need to compare again. So let's see. Now enter the number of elements in array 3. We said 3. Okay. Then I think you have to enter the elements. So 2, 5, and 7. Okay. We say 4, and then we have to enter the elements. So let's enter 3, 5, 9, and 7. Okay, and so the common elements are 5 and 7. That's the last two. We could have done a nice printf before that, saying that which are the common elements, and then it could have come out. Okay, so this is how you would write this code. Okay,
so there are many questions.
Yeah. Now I think somebody had a question. No. So I am facing an error when it's not printing further. Could you please check? Yeah, we'll do 1 or 2 checks for some people. No, what's the name?
Somewhere there. Is there?
You have to note down. Manthan Vijayvargi. Okay, we'll check 1 or 2 codes. We cannot check everyone's, but the rest of you please watch. We will check a few code. Vijayvargi. Okay. Let's watch this program and see if there is some mistake. Enter the number of elements in A. Let me mark it as I go. Okay. Enter the number of elements in A, no problem. N. Enter the number of elements in B, no problem. M. Enter the elements of A. Your array is A. Okay. Ampersand A. Now enter the number of elements in B. Ampersand of B. Oh, I thought this is M.
M.
Sorry, this is M, please. You are writing N again because you are saying I would want the elements in B. It can't be same, no? So print the common elements of A and B are, very good. For K equal to K less than N. Now this won't work because you have read only N, and if these numbers are wrong, you'll have a problem. Okay, so you correct this to M. So for K equal to 0, K less than N, K plus plus is fine. L equal to 0, L less than M is fine. Unless if you correct this, and if AK is equal BL, then printf AK, this is also fine. So if you correct it, you are done. Okay.
she or he can add break.
And after printf, once you have compared it, you can put a break here. Okay, you can put a break here. So you're done. So this is a small bug here. So please change it, and you're fine. Okay. Now, any more? We can check a few more.
Aravinda.
Okay, we are looking at a few more requests. Arvind Agarwal. No, I think he got it, no?
I just
No, if you got it, don't. See, if you have got the code, please don't have to show off. One or two. Okay. We are showing one or two. No, I would like to see people who have not got it.
One doubt is saying this fellow, Aravind Agarwal.
What is the doubt? Yeah, what is the doubt?
Set flag.
Okay, let's. Okay, you want us to go through the program, we'll do it, no problem. Enter the number of elements in A, yes. Int of an, rather, don't do this. You declare the array A big in the beginning. This works sometimes it's dicey.
That only sir is asking.
No, this works sometimes on some systems, this is not standard C. On RC it is working. So better is you use n elements of the array but declare a 100 or something. Okay. This was added, now I am not very sure on our system, it will work always. Okay. So to be on the safe side, just allocate 100 and use n of those. How to allocate dynamically, we will see. I'll come to when I do dynamic memory allocation, we'll see. So that you don't have to allocate more, you have to allocate only as much as required. Okay. But this is not a classic construct. Okay. This is not recommended.
And one more question.
I will not say recommended. I will say not a very good way. Okay.
One more question. Same person.
What is the question?
What if the user crosses 100?
What is it?
We are taking 100.
No. We are assuming that the user will not cross 100. Okay. That is an assumption. We are assuming that n will be much lesser than 100. Okay. So, if that is the only thing, no, some other people are struggling at a basic level. So, let's see whether we can help them. Okay, let's rub it. Somebody who is struggling at a very core level, not able to get.
Mohammed. Spelling.
No, if they have a roll number, no, roll number won't come up there. No,
Yes.
no, give the correct spelling, it will work. Please don't raise hands.
Mohammed.
Muhammad Huzaif. Just say Huzaif. Huzaif. Correct. So, Baba, आ गया.
Roll number.
Huzaif यार. Huzaif. आया ना उधर?
Okay.
Okay, let's see his code. Enter the number of elements in the list. This is okay. Okay, let me go line by line and see if there is a bug. Enter the number of elements in the list. A, scanf, %m, n, %m. Enter the number of elements in A, scanf. This is okay. J equal to 0 is also okay.
Is
For
printing.
I equal to 0, I less than n. Okay, for j equal to 0, print
Is
f.
printing B of I. Which is
You should not print b of I, no? Actually, it doesn't matter. You shouldn't print b of I because b of I may be spurious. You should say a of I, isn't it?
Yes.
Because that is equal. Or you can print b of j.
B of J.
Okay. You can print b of j or a of I. Okay. So that's the bug.
Inka?
Okay. So if that is okay, then you can correct it and run it. We can also correct it, but you correct it. Okay. Anyone else? Namira, Fatima, KMIT. If the common elements in B are more than once, we need to break to display that only once. If the common element is in B more than once, okay. We just say it is there. It may be there one or more times, right? It doesn't matter if it is there one or more times. We break. Yeah, we break that only once. Okay. Ankur Roy, I am having a small problem. Okay, let's look at Ankur's code. Ankur Roy. Okay, Ankur Roy. No, you have not saved it, Baba. Ankur, if you want us to check it, you have to save it. We cannot save it without. We cannot see it without you saving it. You have to save it, then only we can see. Okay, anyone else? Any other question? No, there are quite a few earlier here. You missed also.
That we addressed.
Same elements in the list. Why are we writing scanf in another loop separately? Because you need to read two arrays, right?
Yes, sir.
You gave the answer. Then विषय वर्गी उसके पहले कुछ है? If we break, then we get only one common element. Yes, we get only one common element. We already said that. We are breaking in the inner loop. Yes, we are breaking only in the inner loop. It will take you out of the nested for. Correct. It will not take you out of the outer for. That's the point. Correct. So that you don't necessarily keep. Vemula Vivek. Okay, first was Sai Deva. Sai Deva, do you still need help or is it okay? Go down here. Yes. Sai Deva, do you need help? Devansh, sorry. Okay, you are fine. Then somebody else looked for. Anybody else? Because I think by the time we came down, you may have corrected it. Okay, we'll see this last one and then we'll proceed.
Sai Gautam.
Sai Gautam. Satya Sai Gautam. Sai Gautam. Satya Sai Gautam. Hi.
1P.
What?
1P in the door.
Yeah. Okay, let's see what probably is wrong here. Enter the elements in the array %n. Enter the elements in array 2 %n2. Yeah, please don't do this. Okay. Declare big arrays and then use them. For int I equal to 0, I less than n, scan %a, n1, bj, a and b. Okay, this is fine. Then outer is an int. Okay, outer equal to 0, outer less than n, outer plus, inner equal to 0, inner less than or equal to n. No, it cannot ever be equal to n. Less than n, inner plus, v inner is equal to a outer, then you print a outer. So the only bug I can find is this. You should say less because you can't become equal to that. If you become equal to that, you go out of bounds. You will get a segmentation error or something. Right? So that is a bug. Okay. Okay. So I think this class is till what time?
11:20.
11:20. Okay. So we have time for one more. Okay. Now, since you have some experience with nesting and all of that, you know how to look for one array in another array. I think we are ready to move to another similar kind of problem. Okay, a slightly important variation, but you have to be careful while writing it. Now, I am changing the question a little bit from A intersection B to A minus B, which means I want the elements which are in A but which should not be there in B. It should not be there, that element should not be there in B. If it is there in B, then it should not be printed. Okay, so you have to be a little careful. You'll have to use perhaps the flag to say that it is equal or not, and then you'll have to check whether it is there or not. So I want all the elements in, you'll have to use flag, and you'll have to use a nested for to do this. Now I'll give you 5 minutes, 10 minutes to do this. Is everybody clear what I want? I want all the elements in A which are not there in B.
So they're asking, please repeat their thing.
Repeat what?
Question.
Okay. Okay, I'm repeating again. There is an array A like we had now. There is an array B like we had now. So right now what did you display? The elements which are there in A and also in B, which is called A intersection B. Whatever you implemented right now was A intersection B. Now what I want you to do is, I want you to do A minus B. That is, the element should be there in A, but it should not match with any element in B. It should not match with anyone in B. So if it doesn't match with anyone in B, then it should be displayed. So that is called A minus B. So if A is 2, 5, 7 and B is 5, 8, 9 and let's say 7, then what will you do? 2. Does it match with this? No. 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 It didn't match with anyone. Then 2 should be displayed. Okay. Moment it matches, okay, like here it matches, then you should say that 5 will not get displayed. 7, because it matches with this 7, it should be not displayed. So each element you should check with every element. If it matches, it should not be printed. If it doesn't match, it should be printed. So you'll have to utilize a flag, okay, in this question to do it, because there is a bit of search involved here, and so you'll have to do it little cleverly, and let's see how you do. So all arrays should be called A, the other array should be called B. Are they understand?
They're asking where we have to do it.
Okay. So now where we'll have to do it, I think we'll have to create
one more time.
Okay, just hold on, or let's do it like this. Okay, and you can comment out. I'm sorry. Let's go back to practice 1. We have to actually create another practice, but doesn't matter. Okay, can you comment out the entire code? That is, leave include stdio.h,
like,
and or you can comment the whole thing. Okay, and right like this, and write it in the same. Can you do that? Okay, that should be easy to do. Okay, so do it in practice lab 1. No, this is called practice lab 1. So do it in practice lab 1. Comment out what you have already written. Okay, and write a new one. You can that way borrow code from your code which you have already written into the new one. You can borrow code and make some small changes.
It's already there.
Or what you can do, you can take this code and make changes to it also. That is easier. You can take this code and make changes to it.
And ask them, don't paste the code in chat.
And don't get the code in chat. No, chat is only for talk, not for code. Don't put code in chat. Okay, just do A minus B. And, you can in fact edit the program. No need to comment also. You can edit this program and correct it and get it. Not this one. I think the second one.
Lab 1.
Practice lab 1. Practice lab 1. Okay. Please don't put any code here. Okay.
Tarun Kumar.
Okay. Is what we are asking clear to you? I want to implement A minus B. Elements which are there in A but not there in B. You'll have to use flag and do it little cleverly. Okay, somebody did it. I think two people have done.
Yes, sir.
Nemali Tarun Kumar
Tarun Kumar.
and Nikhil Guru Venkatesh. Okay, we'll look at the code soon. Okay, little change and you will be able to do it. Yeah, Hafiz, Huzaif, sorry. Huzaif will check it later, not now. Okay, we're just taking down the names of people who have done. Segmentation fault comes when you have crossed memory. There is no allocation of memory. You have gone beyond the size of the array, or you have gone into some negative indexes on an array or something. Okay, it can come for many reasons. That is, the address for which you are going doesn't exist. Then you get a segmentation fault. Okay, some more people did. Okay, good. Okay, 11:10 we'll start discussing. Okay, in 2 minutes we'll start responding. . Okay, quite a few people seem to have done. Okay, so I think we will briefly talk about how to do it. So what I'll do is I will go to the original code. If you have one. Okay, or okay, the first person to do, we'll look at that code traditionally. Tarun.
Tarun Kumar Reddy.
Nimali Tarun Kumar Reddy. So this was the person who did first. Okay, I like it already. Okay, good. So yeah, looks okay. Let's walk through this code. Very nicely written. A is 100, B 100, fine. Int n m, fine. Oh, you are putting it in new array. We don't need it. So scanf n m. We already know n and m. Then we are reading the two arrays. This all is all done. Now starts the interesting loop. For I equal to 0, I less than n, that is, he is going through the first array, which is A. He is going through the first array A. This is a very intelligent use of flag. You are making initially flag is 1. Before he enters the inner loop, he is making the flag 1. This is very nice. So he is raising the flag in the beginning. You can do it reverse also, but this is also good. So flag equal to 1, this is beautiful. And then he is going through the inner array, that is the second array, not the inner array, using the inner loop. If he finds that the outer array element A of I is equal to B of J, he is making the flag 0. Okay, the flag 0 means there was a match. There was a match with this element. That is, some A of I matched with some element in B. Because remember, you are iterating through all the elements of B here using this loop. You are iterating. Iterating means looping through all the elements of B using this loop. You are looking at all elements of E for a particular element of A. That is, ith element is being compared with all the elements of B. So if it is equal, he is making the flag 0. And then outside the inner for loop, this is outside the inner for loop. This is the outside inner for loop. If flag still remains 1, what does it mean? That no match was done, because if the flag still remains raised, he is checking whether the flag is this or flag is this. This is 0, this is 1. If the flag is 1, which it was in the beginning, and it was never shut down or it was never lowered, it will be lowered if there is a match. If it is still high, it means that there is no match of this element with anything in the array. So beautiful. So if flag equal 1, we print A of I. Beautiful. So this is how you use a flag intelligently. Of course, you could have made flag equal to 0 and flag equal to 1 here and checked whether it is 0 or not, but this is also perfectly fine. So then again it goes back and picks up. So it's like A0, that is the element of A0 is compared with all the elements of B. If any element of B matches with A0, he puts the flag down and then checks, has the flag gone down or gone up? If the flag is still up, which it was here, that means there was no match. If the match was there, the flag would have become 0. Okay, so because the flag did not become 0, it still stayed at 1. That means there was no match, and then therefore this element is a candidate element to be printed. And then it goes back again to check with the next AI. So initially AI will be 0, I will be 0, so A0 will be compared. Then A1 will be compared. So again A1 will be compared. Again the flag will be raised momentarily, and if there is a comparison, the flag will be lowered. And if the flag is lowered, we know we don't have to print the element. If flag was 0, it means that there was a match, so this element should not be printed. Okay, because it doesn't come in A minus B. A minus B means only elements in A which are not in B. So if the flag matches, then that AI doesn't deserve to be printed. Okay, beautiful. This is lovely. and if it was the first code written, it even makes it even more lovely. Okay, fantastic, good. So this is a very good code, and
They are asking, should we add break after this?
yeah, it would be nice if you can add a break here. Yes, it would optimize it, because once the flag is 0, there's no point remaining in the inner loop. You could come out of the inner loop. Break would be a smart thing to do here, of course. So you could add a break here and then come out, because there's no need to stay in the inner loop. Break will take you out of the inner loop. That is the loop which is still here. It will take you out of the inner loop, and then you can examine the flag. Obviously, if you have done a break, then your flag will be 0, and this won't be printed. So doesn't matter. So yeah, break would be a smart thing to do. It will reduce the amount of time you unnecessarily have to compare. Because even if it compares equally with 1, it's enough. It cannot be printed, right? So that is perfectly fine to put a break here, and I would encourage you to put a break here. Okay, this could be optimized. Yeah. If there is any other doubt, we would like to handle it, take it. We have still a few minutes left in this session.
Is asking.
Elements are getting repeated due to break. No, they won't get repeated due to break. Okay, we'll check Anirudh Joshi first, and then time permits, we'll look at some more code. If the code is correct, please don't bother. Okay. If it is wrong only, please tell us. Anirudh Joshi. Okay. So how many elements? I think I'm not going through that part of the code. I'm going to go here. Okay, I'm not going to look at this. Okay, so A, B. If ARR I equal to, oh, you have not put the flag.
Yes, sir.
See, every time you have to turn the flag 0 in your case. Sorry. Here you have to, before you start, you bring the flag to some condition. So in our case, in your case, I think you should make flag equal to 0. So if flag is equal to 0, so make the flag equal to 0 every time you enter the inner loop. Okay. Before the start of the inner loop, you make flag equal to 0. Then if ARR1 equal to ARR2 of j, then you are making flag equal to 1. And if flag, that means there is some match and you are breaking. And if the flag is 0, then you are printing. That is, flag is not equal to 1, you are printing. That is correct. And next time, else don't make flag 0 there, because that is too soon to decide. Okay, take this out, because it doesn't make sense. Flag not equal to 1, else flag equal to 0. No, because it's not conditional to this happening, right? So take away this. Take away this. Okay, make flag equal to 0 if it is equal. Sorry, make flag equal to 0, not here. It has got, make flag equal to 0 here. Okay. And then test, and again go back with flag equal to 0. Okay.
Without using flag.
Huh?
Someone said have done without using flag.
Yeah, you can do it without using flag, but that would be cumbersome to do. Okay. Okay. Now, if is it clear, Joshi? This is Anirudh Joshi, right?
Yes.
Yeah. Now we can check one code. Somebody else was asking. Uruj Ahmad. Okay. Uruj. Okay, this is Uruj Ahmad. Now I am assuming that this part of the code I am not checking. I am assuming it is okay. For int I equal to 0, I less than n, I plus plus, flag equal to 0, this is good. For j equal to 0, flag equal to 1, break. If flag is still 0, what does it mean? What are you printing here? Why ampersand? If flag equal to 0, that means it was not found because the flag didn't become 1. So this print, that's it.
Correct.
I think you have put in printf we don't use ampersand.
That is a mistake. Okay.
Okay, maybe we have time to check one more.
Check my code. I'm not understanding.
We can't check so many. We can check only a few because we don't have the time. So we will go with Gubba Uday Chandra. We're trying to follow the order as much as we can, but Gubba Uday Chandra. Okay. We'll look at this code and we will have to stop because the time for the next session will start. I'm skipping all this. Flag, don't make flag equal to 0 here. Before you enter the for loop, you need to make it, before you enter the inner for loop. Because see, we are comparing with every element of B, of the second array, right? So before you start comparison with all the elements, you make flag equal to 0. So to correct your code, this should go away from here and come here. Okay. Because for every comparison in I, you first start with flag equal to 0. What does flag equal to 0 mean in your case? That there is no match, right? So make flag equal to 0 in the beginning. But then when you go through each element, when you are comparing, you make flag equal to 1 and 2. And here check whether the flag is equal to 0. Okay? Because when, no, don't compare not equal to. That means every not equal to element will compare. So don't do that. Make it equal to. Because then if you write like this, any element which is not equal to, it may be some other element is not equal to some other element. Okay? No, that don't do that. And this is how you do. If not, this is equal. If it is equal, make the flag 1. And if it is not, then don't do anything. Okay? If it is not equal, don't do anything. It may be equal to somebody else. If it is equal, just make the flag 1 and check whether the flag has still remained 0. If the flag has remained 0, then that element should be printed. And it will print this every time. Okay. So looks like you guys are struggling well. This is how it comes. You struggle a bit, make a few bugs, make a few errors, and as you can see, we can get to correct some of them. And this is how learning happens. Okay. So we will pause here for today, and we'll continue in the next session, that is on Thursday. So are you fine with this system? I mean, are you okay with this system? Yeah. Is this better than the class? No?
No.
Auditorium is better? See?
Yes.
So many yeses also.
No, for auditorium they are saying.
Is auditorium? No, I'm asking, is this better or auditorium is better?